Here we are going to model the same cantilever beam in 2D in Abaqus software. Okay, we'll go to Abaqus. We are going to choose with standard. Okay, I'm going to file set work directory. Here MS Abaqus. Okay, here MS Abaqus folder under C is the folder where it records all my Abaqus files. Okay, I will go to part. I'm going to part manager, create. I'm gonna give name to D beam. It will be 3D, it will be deformable, it will be shell because it's going to be shell element extrusion. I'm gonna make this one 15. 15 will be the scale of the grid lines. Continue, dismiss. Okay, as long as we have only a cantilever beam, if we consider on this section, one line of section, the horizontal one is 0.1 meter. So we are going to draw that 0.1 meter in Abaqus. Here I'm gonna choose line. I'm gonna give starting point 0, 0 enter, and then for the next point I'm gonna give 0.1, 0 enter. Okay, and then escape. Then I'm gonna click done. Here it's asking me to give depth of the cantilever. I'm gonna give 1 meter. Okay. Right now we see that is the shell that we wanted to make it and model it. Now the shell is done. We will go to property where we can give and define material properties. We'll go to create material. We're gonna give steel name, mechanical, elastic, isotropic, and here we record modulus elasticity value 2.07 E plus 11 as it's shown here, the value. Then we will give 0.29 as Poisson ratio. Okay. Okay. We are gonna work on section. We give shell section. It's shell, it's homogeneous, yes, continue. We are going to give thickness 0.1. It's material still, okay. Then we have to assign the section into model. We click on assign section. We click on this model, done. Shell section, yeah. For the definition, we click on middle surface. Okay, the thickness is gonna be in the middle of this surface. Or in other words, I can say that all things will be focused on the middle of the surface. That one will be better. Okay. Now it has been turned into a halving material section. Then we will go to assembly. We click on create instance, parts. We make it independent. Okay. Then we will go to step and click on step manager, create step 1, static general, continue, okay, dismiss, then interaction. I'm gonna give reference point for my force. I will put it here, and then I'm gonna use create constraint, coupling, continue. I'm gonna select my reference point here, done, node region, Okay, for node region, select points for the surface. Okay. I'm gonna click on this and this. And wait a minute. Okay, let me rotate it. Then I'll cancel the rotation. Okay. And I'm gonna click on this point and this point. Okay, I'm gonna choose this edge. Done. Structural distributing. Okay. Now this edge has been linked to the reference point where we apply force. Then we'll go to load boundary condition, fix it. We apply it on initial step, symmetry and symmetry, and continue. I will choose this edge. Done. I'm gonna make it encapsulate to make it fixed. Then for loading, point load, step 1, concentrate force, continue. I'm gonna choose my reference point. Done. On y-axis, I'm gonna apply 100 Newton negative as downward. Okay, that's done. Then I have to go to mesh. Okay, I'll click on my part 2D. Okay, let me make assembly. I'm gonna make it 0.08. Apply. Okay, I'm gonna mesh it. Yes. Or let's make it final. I'm gonna click on mesh again. I'm gonna make it 0.04. Apply these meshes. Okay. I will click on mesh part instance. Yes. Okay. Mesh is done. Then let's go to job. I'm gonna create my job. I will name it beam job. Continue. Okay. Then I have to submit my job. Beam job is already here and I'm gonna submit it. It's gonna be running and I will wait for the results. Okay, as it says it's completed, I'm skipping to results. I will go to U, deform shape, okay. Okay, let me choose U2 for y-axis. Let me choose auto feed view, okay. Yeah, so the value is 1.939 multiplied into the power negative 5 meter. The deflection is here, written here is as same as the value that we had recorded in the table. Let's go to 2D 1.94 and this one is 1.939. Okay, let's make XY data ODB field, continue. Let's choose unique nodal U2. Then let's go to element nodes, edit section. We will click on our reference point. Okay, or there's something else. Node labels, node sets, internal sets, node sets. Okay, yeah, this our reference point. We'll choose this one. Plot, dismiss. We'll come to here. It's our information about displacement of reference point. We click link right, edit, and here is the accurate value of the displacement of the reference point. Okay, we are gonna save it, save as. We will give a name 2D beam in CAE forum. Okay, that's done.